Hello, ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 2 class. This is going to be Section 2.1, Solving Linear Equations and Inequalities. So let's go ahead and write that down. Solving linear equations and inequalities. Well, first we have to know what a linear equation is, what a linear inequality is, and then we have to be able to solve it. So here we go in beginning with that. We're going to start with our definitions. So an equation is two algebraic expressions that are compared over an equal sign. I'm going to call it an inequality sign, because it could be equal to, it could be greater than, it could be greater than or equal to, it could be less than, it could be less than or equal to. But an equation is two algebraic expressions that are compared over an inequality sign. So an example would be something like, if I don't use highlighter, would be something simple like x is equal to 2. This is an equation. We have two algebraic expressions being compared over an inequality sign. Very basic one. But some are more complicated. For an example, 2x minus 4 is equal to 12. This is another equation because it is two algebraic expressions being compared over an equal sign. I know what you're thinking, but Mr. Neal, 12 isn't an algebraic expression. Well, it is. If you add 0x to it, it becomes an algebraic expression. But 0 times anything is 0, so we don't normally write it. So it's kind of invisible, but it's still there. So we have two algebraic expressions being compared over an equal sign. Now, next up is, what does it mean to be a solution? A solution to an equation is a number or set of numbers that can replace the variables and create a true statement. For example, let's use the one that we used earlier. 2x minus 4 is equal to 12, and we are told to find the solution. Well, to find the solution, we would have to solve for x. So to solve for x, add 4 to both sides. And we now have 2x is equal to 16. Divide both sides by 2, and we get x is equal to 8. Now, 8 is the apparent solution. It isn't necessarily the solution to this. To find the exact solution, we have to double check it. To double check it, we need to, of course, plug it in and see if it works. So let's do that. Let's plug it in and see if it works. We'd have 2 times 8 minus 4 being set equal to 12. 2 times 8 is 16. So now we have 16 minus 4 is equal to 12. And then 16 minus 4 is 12, so we have 12 is equal to 12, which is a true statement. Therefore, 8 is a solution to this particular equation. And now we have linear equations. So what does it mean to be linear? Linear, of course, means line. So A linear equation is an equation where the power of every exponent on a variable is 1. I'm going to put the number 1 right there. There. Because we are number 1. Yay! All right, so a linear equation is an equation where the power of every variable is 1. So for an example, let's say that we are given y is equal to mx plus b. Where are the variables? Well, the variables are y and x. What is the power of each variable? Well, the power of each variable is 1. So this would be a linear equation. But what about y is equal to x squared minus 4? Well, this one is nonlinear because one of our variables has an exponent that is not 1. Now, what about z is equal to 4x minus 3y plus 21 q minus 47, pick another letter, k. Okay, there. What about that one? Is this one linear? Well, yes, because every exponent has a power of 1. So this is a linear equation in a lot of variables. What we're going to be working with is not going to be nearly this complicated. We're going to keep it simple. We're going to just work with one variable and maybe sometimes 2 variables later on. We're not going to go into 3 variables in this course. Actually, we are, just not yet. So we're going to keep it to about 1 variable for now, and we're going to expand on it once we get it down. So linear equations are equations where the power of every exponent on a variable is 1. But what about something like y is equal to 1 over x? You'd be tempted to say, well, Mr. O'Neill, look, this one has a power of 1. And I would say, nope, that's really the power of -1. So it doesn't work. Sorry, guys. All right, actually, I'm going to leave that up there. It's a good thing to see. All right, so this one would be not. This one would be not. This one would be, and this one would be. Okay, so let's go ahead and go to the next page. And on the next page, we are going to learn about how to solve them. You should know how to solve them. All of Algebra 1 was solving these things. You're in Algebra 2 now. You should know how to solve them. An example. If we saw 2x minus 4 is equal to 8x plus 12. How would we solve it? Well, to solve solve for x, we would say, all right, well, let's get all the x's on one side. So I'd subtract 2x from both sides. That would leave me with -4 is equal to 6x plus 12. Then I'd subtract 12 from both sides. And now I get -16 is equal to 6x. Then I'd divide both sides by 6. And I would have x is equal to -16 over 6, which is -8 over 3. So -8/3 would be a solution to this particular linear equation. Alrighty then. Let's see if we can do some examples besides that one. Let's look at solving the equation for y given 5 times the quantity of y minus 7 is equal to 25. Now before we go any further, I want to talk about how you solve. And this is going to be Mr. O'Neill's rule of thumb. So Mr. O'Neill's rule of thumb. If I can spell thumb. There we go. Mr. O'Neill's rule of thumb is this. To get rid of addition, you add. To get rid of multiplication, you multiply. To get rid of exponents, you use exponents. Etc., etc., etc. To get rid of something, you use that something to get rid of it. The other thing is, when we are solving, we use the reverse order of operations. Our order of operations is usually Gemma. But when we are solving, we want to go in the opposite direction. So we would have AMEG. So solving order of operations, you want to get everything into its simplest form first. So you kind of go Gemma first, and then you do AMEG. But when you're solving, you're really doing just the reverse order of operations. You do addition before you get rid of the addition, before you get rid of the multiplication, before you get rid of the exponent, before you get rid of the grouping symbols. Okay? So let's look at this one. First things first is we do the Gemma portion of it. We do our order of operations to make it as simple as we possibly can. So I do 5 times y and then 5 times negative 7. That would give me 5y minus 35 is equal to 25. Then I need to do the reverse order of operations and get rid of the addition first. So I would add 35 to both sides. And that would get me, let's see, that's 60. And then I would have 5y is equal to 60. And then I would multiply both sides by 1/5 to get rid of the multiplication. In which case the 5's cancel on the left. I'm left with y. And then on the right I have 60 divided by 5, which is 12. And then 12 times 1 is 12. So we have 12. Now, could we have done this a different method? Well, yeah, sure. If I saw 5 on the outside of y minus 7 is equal to 25, I could also start with getting rid of the multiplication and multiply both sides by 1/5. And when I do that, it cancels this exterior portion. I'm left with y minus 7 is equal to 25 divided by 5 is 5. And then I could add 7 to both sides and get y is equal to 12. Now, which one of these ways is the correct way of doing it? The answer to that question is both ways are the correct way of doing it. You can use either method. If you find a way to do something that's easier than the rule of thumb, then do it. The only part about the rule of thumb that you cannot get away from is this portion. To get rid of addition, you have to add. To get rid of multiplication, you have to multiply. To get rid of exponents, you have to use exponents. That is the one part of it that you really, really, really don't have any room to maneuver on. But as for the order of operations portion, do what works best. I prefer to simplify things first, or expand them, or whatever it takes. It's just whatever you think will make it easiest, you can do. Sometimes you'll be wrong, and you'll have to do something harder, like I did on the first one. And sometimes you might be right, and you'll do it like I did on the second one, and it'll be super easy. To each their own. All right. Next up. What happens if you have variables on both sides of the equation? Oh my goodness, that's going to be a doozy. Both sides of the equation? Why does it have to be so complicated? Well, because it's life. All right, let's look at 6y plus 21 plus 7 is equal to 4y minus 20 and then plus 5y. Now on this one, the first thing I would want to do is combine all of my like terms. That's just a habit that I've been in for a long time. So I'm going to add the 21 to the 7 and get 28. And then I'm going to combine the 4y and the 5y and get 9y. So now I have 9y minus 20. Now I need to get my y's on one side and everything else on the other. So to do that, I would probably take the 6y and move it over. Actually, I should say I would subtract 6y from both sides. That would eliminate it on the left and give me only what's left on the right. So then I would have 28 is equal to 3y minus 20. Now I got to get rid of the 20. To get rid of the 20, I would add 20 to both sides. So I add 20. And now I have 48 is equal to 3y. Now I need to get y by itself, so I divide both sides by 3. Or actually multiply both sides by 1/3. So let's use a different color for that. Multiply by 1/3. The 1/3s cancel with a 3 on the right hand side, and I'm left with just plain old y. And then I do 48 divided by 3 is 16. 16 times 1 is 16. I have isolated my y. I have a solution to this linear equation. All right. Now, what about inequalities? Well, those are a little more complicated. With inequalities, if you multiply by a negative number, then the sign flips. For an example, 4 is obviously less than 10. That is correct, right? Now, the same rule applies. What you do to one side, you must do to the other. But when we do this, if we were to multiply both sides by a negative number, say negative 2, then the inequality sign must flip. And when we do that, we would have negative 8 is greater than negative 20, which is also a true statement. So when we're working with inequality signs, we really have to be very, very, very careful about our multiplication, because they can make our sign flip multiple times as we go through. And it's also why it's really important to show your work, because if you forget to flip it on one of them, but you flip it on all of the others, then you'll still be wrong. But you won't be so wrong that Mr. O'Neill will take off all your points. He's actually pretty merciful when it comes to that sort of thing. Because if you show that you remember to do it like on 4 out of the 5 times, it's like, oh, well, it happens. Everybody forgets every once in a while. So let's look at a really simple inequality that we're told to solve for x. And we have 9x plus 4 is less than 12x minus 11. Now when I'm doing this, I have to keep track of the inequality sign all the way through. If I don't, it will come back to bite me, because inequality signs, if you look at them, they look like a giant Pac-Man. If you put teeth on them, they look like a really angry Pac-Man that's going to eat you, which makes me want to run away. Anyway, so let's go ahead and work with this one. On this one, as I said, I've made a habit of putting all of the x's on one side where they're positive, because of the problem with multiplying by a negative sign. But in this case, I'm going to go against that rule. I'm going to start by subtracting 12x from both sides, so that I can have my x on the left. And when I do that, let's see, 9 minus 12, which is more like 12 minus 9 is negative 3. So I have negative 3x plus 4 is less than negative 11. And then I subtract 4 from both sides. And when I do that, I have negative 3x is less than negative 15. Now, here's the part where we have to remember that rule. Whenever you multiply by a negative number, the sign flips. This is also why multiplying by a fraction makes way more sense than dividing. Because if it was dividing, I would have to include a second rule that says whenever you divide by a negative number, you have to flip the sign. So I'm going to multiply both sides by negative 1/3. When I do that, my inequality sign flips. And then I can do the arithmetic. Negative 1/3 times negative 3 is positive 1, so I'm left with x. And on the other side, a negative times a negative is a positive. 15 divided by 3 is 5, times 1 is 5. So I would have the solution set of x is greater than 5. Now when we do these, we might be told to graph them on a number line. So if I was to graph this on a number line, the first thing I would need to do is draw a semi-straight line and pretend it's a number line. Please pretend that this line is straight. And then in the middle, we'll have a little tick mark, and that will be our origin point. In this case, I'm going to make that origin point 5. Like, but Mr. O'Neill, your origin point is supposed to be 0. And I'm going to tell you, no, it's my number line. I can make it any way I want to, as long as I follow the right rules. Now, underneath this, you'll notice that we don't have a bar. Now, if you guys have ever been hit by a bar, you know they're pretty darn solid. But if you've ever been hit by a bar of air, you're kind of like, what was that? Don't feel anything, right? So it's not very solid. So when we see this sign and there's no bar underneath, it's not going to be a solid point. It's going to be an open circle. And then from there, we need to do a test point. We need to find out which way it's going to go. Does it go to the right or does it go to the left? To figure that out, I would plug in a test point, like 6, and see if it makes a true statement. Is 6 greater than 5? It makes a true statement. 6 is bigger than 5. So if true, go through. If false, flee. If true, go through. If false, flee. So for an example, if I was to pick this point over here, which would be 4, and let's do this in a different color other than blue. Let's do it in red. Like if I picked this point over here, which is at 4, I would plug it into the same thing. I would say 4 is greater than 5. Is 4 greater than 5? No. So this makes a false statement. If it's false, I flee from that point, meaning I go the, I hate to use this word, opposite direction of that particular dot. So instead of going to the right all the way to infinity, if it was true, it wasn't true, it was false, I would go the other direction. So instead of going left to infinity, I would instead go right to infinity. If true, go through. If false, flee. All right. And that, ladies and gentlemen, is the entirety of our lesson for today. Let's go ahead and jump straight into your favorite part, which is the homework. Our classwork for today is going to be in section 2.1, which is on some page in your textbook. Please feel free to look it up. And we are going to be looking at numbers 3 through 19 odd. And then we're going to do 21, because aerospace is cool. And then 23, 27, 31, 35, 41. Actually, not yet on 41. I think we need to do 37 and 39 as well, just for extra practice with inequalities. 41, 43, and then 60 through 150 all. which, by the way, don't exist. So, yeah, we're just going to erase that. Haha, fooled you. There's your assignment. Good luck and have fun.